Okay, so let's put the screen up. Looking in Google Classroom this week. All right, this is week 34. So we have the Unit 4 test right there. It's posted. It's informative. We also have a test review right here. So I have this document right here. When you click on that, it will pull up that document for you. So this is what we're going to go through in class to put the answers to this review. But this is the type of questions you will see on the test. So if you can do the review, you can do the test. If you can do the review without any help, then you're in great shape. So let's pull it up here and see what we're doing. All right. Let's look at the review. So the review starts out with a couple of these. Given the graph, you don't have the equation, you just have the graph. Determine whether this is A, that's the A spot. Is this an even or an odd degree function? And B, is the leading coefficient positive or negative? All right, so we should be able to easily determine that with a graph. This one, the end behavior, the left end goes down and the right end goes down. Well, that tells us right away, since they're both going the same direction, this must be an even function. Has to be an even function because they're going the same direction. This one, one's going down and one's going up. The two ends are opposite. So that is an odd function. So we know this is like a x squared, x to the fourth, x to the sixth, x to the eighth, some even number. This is like an x to the third, x to the fifth, x to the seventh, x to the 13th, some odd number. But we don't know the function. We just know they're even or odd. And B, the leading coefficient. Is it positive or negative? Well, this is even. So with even, either both ends go up or both ends go down, one or the other. This happens when it's a positive coefficient. This happens when it's a negative coefficient. So this is obviously a negative coefficient because these are going down. So that's a negative coefficient. With the odd functions, you either have this when it's a positive coefficient, or the left side goes up and the right side goes down. Well, ours, the right side goes up and the left side goes down, so that's positive. This is a negative right here. All right, let's look at the next ones. Graph the function below and identify its key characteristics. So I've taken this function and I have put it in Desmos for us, so we already have it graphed. So I'm going to copy that graph to our paper real quick. It goes down. Here, 3, 4, 5. So I'll graph us. But overall, that's a pretty accurate replication of it. So the domain are the x's, right? Well, what's the lowest x on this graph? Well, it goes forever. This goes to infinity, and it keeps going left. So the domain will go all the way to negative infinity. The largest x for this, well, that's continuing. While it's going down, it's also going to the right forever. So it goes negative infinity to infinity. So this is an easy one as far as that goes. How about the range? The smallest y. Well, this goes to negative infinity. So it goes from negative infinity all the way up to infinity. So this was an easy one. They both went from negative infinity to infinity. You know, if we didn't have this part and this just went down, then the y's would go from negative infinity all the way up to this. And it would stop right there. There wouldn't be any y's larger than that. But since it loops back up, it goes on. Our range goes all the way to infinity. All right. What's our relative maximum? Well, let's see. This is goes on to infinity. That's not it. This is a low point. That's a minimum right there. That's a relative minimum. That'll be right there. That's a relative maximum. That's the highest point in that part of the graph. So we need to go to our Desmos to get that exactly because we don't have that point. So our relative maximum is at 4.12. Doesn't get any bigger than that either way. So 4. Click on it again. You write that as my maximum. 4.12, comma, 4.061. Okay, so we've taken that point and we've made that our maximum right there. 4.12, 4.061. Relative minimum. So the smallest right there. That's smaller than everything on both sides of it. So that's a relative minimum. So that, let me write that one down, is at 1.214, comma, negative 8.209. All right, so that point is our relative minimum. That's right there. All right, the end behavior. As x approaches, what? Infinity. That says as the x goes that way, approaches infinity. As the x gets bigger and bigger, what does the function do? Well, the function goes down. So it's approaching negative infinity. It never stops. So the closer x gets to infinity, the closer the function gets to negative infinity because it's going down. So now as x approaches negative infinity, so as it goes this way, approaching negative infinity, the function is going up. It's approaching infinity. The farther the x goes negative, the more it rises towards infinity. All right, increasing intervals. When is it going up? Well, let's see. You always start from the smallest, the left side of the graph, going this way. So as we go this way, the function is going down. It keeps going down till it hits right there. Then it's going up between there and there. So when it gets to this point, all the way to there, in between that interval, in between when the x is this value and the x is that value, it's going up. And what are those x's? Well, we have those right there. That's our x's. So it increases between, we do it smallest to largest, 1.214 up into 4.12. So this is when x is 1.214 and that's 4.12. In between there, it starts down here. We can see it better with the ruler. It's way down here at that point. And then as the x goes, it's getting bigger and bigger and bigger until right there. Now it's not getting bigger anymore. So that's the interval that's increasing. Decreasing intervals. Well, there's two of them, right? It's decreasing all the way until it gets to there because we see the graph going down. And then when it starts decreasing again all during that interval. So all the way from negative infinity, and oops, don't need to close the parentheses yet, all the way from negative infinity until it gets to 1.214. At 1.214, it's not increasing nor decreasing. It stops, turns. Then again, it starts decreasing again at the 4.12 all the way forever to infinity. Now it wants the zeros. Well, let's go look and see exactly where the zeros are according to our Desmos. There's one at 0, there's one at 3, there's one at 5. So 0, 3, 5, 3 zeros. So that's it, just key characteristics of graphs right there. So now let's go down here. Name the zeros and their multiplicity and the effect of the multiplicity. All right, so the zeros. This is in factored form. We like factored form because all we have to do is take the factors instead of x equal to 0. So negative x equals 0, so x equals 0. All right, when we divide by negative 1, we just get 0. So the first one is at 0. What's the multiplicity? Well, it's not x squared. It's not x to the third. It's just x. So it only has a multiplicity of 1. So that's odd. 1 is an odd number, so that means it will cross. That means it crosses the x-axis. It crosses the x. Okay, what's the next one? 3x minus 2 to the fourth power. Well, so we know there's 4 of these zeros because it's to the fourth power. But 3x minus 2 equals 0. Add 2 to each side, so 3x equals 2. Divide both sides by 3. So x equals 2/3. So 2/3 is another 0. It has a multiplicity of 4, which is an even number. So it bounces off the x. It just touches it and goes back. Whether going up or down, it's going to bounce back up or down. Now we got x plus 7 squared. Squared. So there's 2 of these zeros, which means it will also bounce. And x plus 7 equals 0. Subtract 7. So x equals -7. X equals -7. So -7 is the last 0. So there's our 3 zeros. There's the multiplicities. There's the effect. Crosses the x, bounces, bounces. All right, this one, a little trickier. It is not yet factored, so we have to factor that first. So the first thing we can do is we can factor an x out of every term, because there's an x squared, and x to the third. So x times, we take an x out of every term. It comes to that, x squared plus 10x plus 25, and x. So x being one of the factors, we know it's just x equals 0. And there's just one of them. And so it will cross the x. But now we need to factor this. So we need 2 numbers that would multiply together to be 25, but add together to be 10. Oh, so this is going to factor to x plus 5, x plus 5. Because when you multiply 5 times 5, you get 25. When you add 5 plus 5, you get 10. So that is what this factors to, which is the same as x times x plus 5 squared, because it's 2 of them. 2 of them. There's a multiplicity of 2. And x plus 5 equals 0. X equals -5. The 0 is at -5. And it will bounce because it has a multiplicity that's an even number. And there is no third. Now we know there should be 3 because x to the third is the largest. This one's x to the 7th because you got x times x to the 4th times x to the 2nd. So there should be 7 altogether. There is 1 plus 4 more plus 2 more. There are 7 solutions to this one. It's just there are a bunch of repeating. 4 the same that, 2 the same that. 3 here. There are 3. There's 1 0 and 2 -5s. So here we go. All right. Let's see what's on the back. It's just a 2-page review. So we're halfway through. A polynomial function has a 0 at, it tells us the zeros. Here's one at 4. There's one at 1. And that's it. And they want us to write a function in factored form. That's going to make it easy. That could represent this function. So if there is a 0 at 4, if we set that equal to 0, we subtract 4. So that means it's x minus 4. That's the factor. If 4 is the 0, then x minus 4 is a factor. So f of x equals, this is one of the factors, x minus 4. And what does it tell us? Multiplicity is 2. So that means there's 2 of those. It's squared. And there's one at 1. So if 1 is right, that means that factor is x minus 1. So the other factor is x minus 1. And it has a multiplicity of 1. So it's just the first power. So that's our answer right there. This is in factored form. And all we had to do is take the 2 zeros, turn them into factors, which means they should be set equal to 0. If x equals 4, we need to move it over so it's equal to 0. And that's our answer. Multiplicity 2, multiplicity 1. All right, now we have factoring. A lot of factoring here. So factor each polynomial completely. X to the fourth minus 10x squared minus 39. No greatest common factor, but we should be able to split this into two factors. Since this is x to the fourth, it'd be x to the squared. And we need two numbers, if we can do it that way, that would multiply together to be 39 and negative 39 and add together to be negative 10. Well, there's not much that can multiply to be 39 or negative 39. 1 and 39, and one of them would have to be negative. 3 and 13, and one of those would have to be negative to make it a negative 39. And that's it. There's no other numbers that multiply to be 39. Well, this will work real well. If this one's the negative one, 3 plus negative 13 is negative 10. So if we make this positive 3 and negative 13, that's the factors. And can we factor this anymore? No, that's going to be a negative number, because if it's x squared plus 3, instead of equal to 0, it's x squared equals negative 3. So it would be the square root of negative 3. So that's going to be imaginary numbers. So we're not going to factor that any longer, because that would be imaginary numbers, because that's going to be the square root of negative 3. X squared minus 13. Well, actually, I think we can play with that one a little bit. If x squared minus 13, what does that mean our x's are? It's not going to be a whole number, so I would stop factoring there. You could say x squared, if it equals 0, equals 13, because you add 13 to both sides. So then x equals the square root of 13, plus or minus, because you take the square root of both sides. So if that is it, then your factors are x plus the square root of 13 and x minus the square root of 13. But when you get down to rational numbers, a lot of times the factoring usually stops at whole numbers, unless you're specifically said to factor further than that. It does say completely. So it does say completely. I might go with x squared plus 3, x minus the square root of 13, x plus the square root of 13. I would take either answer. You can factor that down to this, and you can factor that to 3i and negative 3i. But I'd be fine with you stopping at that. Now, if this was a perfect square, like x squared minus 4, you would definitely need to factor that further, because it'd be x plus 2, x minus 2. But if it goes down to where it's not a whole number, I'm fine with you stopping there. All right, let's look at this one. Let me draw a line so I don't get that confused. All right, 4x squared plus 16, x squared plus 15. All right, again, there's no greatest common factor. This is 2, you can factor out of there, 2 out of there, but you can't factor out of 15. So we need, again, to find a way to break that up. When you got 4 times 15, so it's 60 is the number we're trying to reach. 60. Because you got to take the coefficient of here times the coefficient of there. This was just a 1, so that's why we just used negative 39. So with 60, you got 1 and 60. We're wanting to break this up. 2 and 30, 3 and 20, 4 and 15. And let's see. Can we do 5 times something? Yeah, 5 times 12. 5 times 12. 6 times 10. 7, 8, 9. So that should be everything that goes into that. And we got this 4 over here. So if it broke up nicely, we need to add together to be 16. And that's a positive. So they could be 2 negative, 2 positive. This is a positive. So let's see, 61, 32, 23, 19, 17, 16. We go all the way to the last one before we get them to add together to be 16. We're going to divide this up. Since it's a 6 and a 10, we would say 4x to the fourth plus 6x squared plus 10x squared plus 15. What we did is when you have something like this, you're going to take the 16 and rewrite it as a 6 and a 10. See, I took the 16x squared and I rewrote it. That's how I had to find these numbers to figure out what numbers to use to rewrite that. Then we do the grouping. Remember the grouping? What factors out of here? 2x squared factors out of there. So 4x to the fourth divided by 2x squared equals 2x squared. 6x squared divided by 2x squared is a 3, because 3 times 2x squared gives us back to that. Well, what can we factor out of here? We got a 15 and a 10x squared. The only thing that factors out of there is a 5. And that leaves, when you divide it by 5, 2x squared. And divide 5 of that plus 3. Okay, I'm going to erase this little x thing. We just needed the 60. So when we look at that, we have two terms with the 2x squared times this, and we have the 5 times this. These are the same. We can factor that out. So that leaves us with 2x squared plus 3 as one of our factors. And the other factor is the 2x squared plus 5. 2x squared plus 3, 2x squared plus 5. I was jumping to divide those by 2, which ends up at 3 and 5. So we still end up in the same way. But we need to do it through the proper steps instead of assuming something. So that's our answer. And you wouldn't take that down any farther because you're going to get into fractions and stuff. So we just factor it down to there, just like we can leave that at that. So, all right. What do we have here? We can factor a 2 out, and that leaves x to the, oh, we can actually take a 2x out. They each have an x also. So let's take a 2x out. 2x, x squared plus 6x minus 16. All right, so we need something that multiplies together to be negative 16, but adds together to be a positive 6. Well, negative 16 would be 1 and 16, or 2 and 8. Oh, 2 and 8 would work. Since it's negative, one of them have to be negative. So this would break out to 2x and x minus 2 and x plus 8. And that's as far down as that factors. And this one's got a to the 5th b minus 64ab. Well, the only thing they both have is they both have an ab, which leaves this as a to the 4th minus 64. The ab comes out of there. This is the difference of squares. Both of these are a square. So that would factor to ab, a squared plus 8, and a squared minus 8. And since this is a difference, but it's not squares, 8 is not a square, we'll leave it at that. We won't factor that any farther. Okay, this says solve the following polynomials by factoring. That's just one step farther than we had here. Because first we have to factor them and get them into the factored form like we do here. But then we set it equal to 0, and that's how we solve it. So let's look at this one. X to the 4th, 13x squared plus 40. So that would factor into x squared plus something and x squared plus something else, because these are all positive. So both factors will be plus. So numbers that multiply together be 40 and add together 13. Well, 40 is 1 times 40, 2 times 20, 4 times 10, 5 times 8. 5 and 8 add together to be 13. So x squared plus 5 and x squared plus 8. Those don't factor any further. So now we just set them equal to 0 and solve. X squared plus 5 equals 0. And over here we got x squared plus 8 equals 0. Subtract 5. X squared equals negative 5. Over here we subtract 8. X squared equals negative 8. To go from x squared to x, we have to take the square root. So the four solutions, x squared becomes x square root of 5. So this is plus square root of negative 5 minus square root of negative 5. Notice those are both imaginary answers. And we have the square root of negative 8 plus square root of negative 8 minus square root of negative 8. And yes, you could write it plus or minus the square root of negative 5. Or you could also write it plus or minus 5i instead of whatever I said here. Those are all the same. Either writing them separately as factors, as a plus or minus that, or pulling the I out. Those are all the same answer. These are the same as this, same as this. So whichever way you prefer, but there are four solutions, but notice they are all imaginary, because if you graph that, this equation will not touch the x-axis anywhere. And the reason we know that is because it's x to the fourth, it's even, so it's going to look like this. It's going to go up because it's a positive coefficient, but the y-intercept is 40. This is way up at 40. The 0, the x-axis is way down below that. So it never touches the x-axis. That's why all the solutions are imaginary solutions, because there's no real solutions to that. All right, what can we do with this? Well, we've got to subtract x squared from both sides, because we've got to move everything over to where it's equal to 0. And we've got to subtract 8 from both sides. So that leaves us with x to the fourth minus 2x squared, because we had a negative x squared, we subtracted another one, and then minus 8. So that will factor to x squared, well, plus something, and x squared minus something. We need negative 8, so that'd be 1 and 8, 2 and 4, and that's about it. And one of them would be, it's a negative, so the bigger one would be negative. It's either 1 times negative 8 or 2 times negative 4. And we need it to be a negative 2, so it's obviously that one. So plus 2 minus 4. X squared plus 4 plus 2, that can't be factored. This is the difference of squares again. So it's looking at x squared plus 2. And then this is x plus 2x minus 2, using the difference of squares, that shortcut. If you have both of these that are squares and they're subtracting, we can use that shortcut. All right, factoring's done. Now we need to do the solving. So x squared plus 2 equals 0. Minus 2, x squared equals negative 2. So x equals plus or minus the square root of negative 2. That's a solution. There's two solutions there, plus and minus. X plus 2. So when x plus 2 equals 0, that means x equals negative 2. So x equals negative 2 is a solution. X minus 2 equals 0. So that means we add 2 to 0. So x equals 2. So plus and minus 2 is a solution also, because this will be x equals 2. So x equals 2 plus or minus, and plus or minus the square root of negative 2. So two real solutions. It will actually cross the x-axis at 2 and negative 2. These are imaginary, so it will not. But we should have found 4 solutions because it's to the 4th power. Same thing here. 4th power, 4 solutions. This one's 3rd power. We only expect 3 solutions. All right, so how can we do that? We can group this. We got 4 terms, so with 4 terms, we group it. What factors out of 4x to the third and 5x squared? Well, the only thing that'll factor out of that is x squared. And that leaves 4x plus 5. Negative 16x minus 20. The only thing that'll factor out of that is a negative 4. And that leaves negative 4 from negative 16x is a 4x. Negative 4 factor out of negative 20 is a plus 5. Both of these terms have a 4x plus 5. So 4x plus 5 is one term. And the other term is what's left. X squared minus 4, which also factors to, let's see, 4x plus 5. That's difference of squares once again, just like we had right over here. X plus 2, x minus 2. So what's our solutions? Well, this one is negative 2. That's one of our solutions. That one's 2, because set those equal to 0, you get negative 2 and 2. But what is this one? Let's see, 4x plus 5 equals 0. Subtract 5. 4x equals negative 5. Divide by 4. So negative 5/4 is a solution. It's x, negative 5/4. So we do have 3 real solutions. It will actually cross the x-axis at negative 5/4, negative 2, and positive 2. All right, one more. X to the third minus x squared equals 20x. Got to subtract the 20x from both sides. So that leaves us with x to the third minus x squared minus 20x equals 0. We're going to factor out an x. X squared minus x minus 20. We're just setting it equal to 0 to give our solving part of it there. X squared minus x minus 20. That factors. We need a number that multiplies together to be this, 2 numbers, and add together to be this. Well, that's x plus 4, x minus 5. So with all those equal to 0, x equals 0. That's one of our solutions. X plus 4 equals 0. You'd subtract 4 from both sides. So negative 4 is a solution. And x minus 5, you add 5. So 5 is the solution. So there's the 3 solutions. Again, it's x to the third, so we expect 3 answers. All right, and our last 2 review questions for the test. Find the quotient of the following polynomials using either, oh, you got your choice there, synthetic or long division. All right, let's do this first one by long division, and we'll do the second one by synthetic division. So we show one of each. So I need to set it up, x minus 1 divided into x to the fourth plus 5x to the third minus 3x minus 1. So how many times does x go into x fourth? It goes x to the third amount of times. X to the third times x is x to the fourth. X to the third minus negative 1 is negative x to the third. And we're subtracting. So that's nothing. Subtracting a negative means we add that. So we've got 6x to the third. That comes down. So how many times does x go into 6x to the third? Well, it goes in 6x squared amount of times. Notice we didn't have a 6x squared, but we've got 6x squared amount of times. So we not having that, we kind of messed that up. We've got to account for that. We have 0x squareds. And then minus 3x minus 1. So we've got to make sure it's lined up properly. 0x squareds. So how many times does it go into 6x to the third? It's still 6x squared. So we multiply that 6x third. This is plus 0 x squareds. So 6x squared goes 6x third, and then 6x squared times negative 1 is minus 6x squared. Okay, so again, subtracting that. This goes away. That means we're adding. So we have 6x squared minus 3x. How many times does x go into 6x? squared. It goes in there 6x amount of times. 6x times x is 6x squared. 6x times -1 is minus 6x. That goes away. We're subtracting, remember. So this is an adding 6x. We've got 3x and we have -1. How many times does x go into 3x? It goes in there 3 times. So we got 3x minus 3. So we have a remainder of -2. All right, hold up. Let me stop me right there. Mr. Brock, you forgot you were subtracting this right here. And when you subtract -3 from -1, it's like adding 3. It's a +2. So just want to make sure you get that corrected before we move on. Now, please proceed. Remainder of -2 x minus 1s. So we can just say plus x minus 2s. Plus -2x minus 1s. That's long division. Let's do this with some synthetic. Remember, if it's x minus 5, then we're dividing by 5 because x minus 5 equals 0 would make x equal 5. 5 is the 0. With synthetic division, you're dividing by what the 0 solution is, which is a +5. So 5, and we just the coefficients. We have got 1 x thirds. We have -12 x squareds. We have 33 x's, and we have a constant of 0. Constant of 0. So remember, with synthetic division, the first number just comes down. Then you multiply, add, multiply, add, multiply. So that makes this x squared minus 7x minus 2 with -10x minus 5s. Synthetic division, long division. So I think you have a choice of using either one of those on the test as well, because you could do either one here. You could have done both of these by synthetic or both these by long division, whatever you like. So if you struggle with any of these problems on the review, go back to the actual week where we did those things. We have videos of where we actually went through those. This is just reviewing everything we've done the past few weeks. So you can go back and review that if you need to before you take the test. That's it. The test will look just like the practice form. So you can go print out those practice forms and see if you can do them yourself and then check them against the key. Like I said, I'm going to upload this so you can check it against the work we did here in class. But otherwise, go have a great week. This was a B Friday. So you need to be here. You'll just need to be here Wednesday. Time's moving on. Get your stuff turned in. We'll see you next time.